Hi students, I am Ila Arora and in this video we are going to discuss what are electronic transition. So for that I am drawing two energy levels. Suppose this is your E1 and this is E2. So one electron, if it is moving from E1 to E2 or E2 to E1, means when the electrons are doing movement from one energy level to another energy level, that will be called electronic transition. I hope now you understood the movement of electron from one energy level to another energy level, that is called electronic transition. Now next question is how it is happening. So suppose we are providing electromagnetic radiation to one molecule. This is our molecule. So when this molecule will absorb some kind of radiation, the electrons present in this molecule, they will absorb the radiation or energy and they can move from the ground state level to excited state level. And after some time, these electrons can again go from the excited level to ground state level. So this kind of movement, that is called electronic transition. Next question is, what are the type of transition? So for this, you can see this diagram. In this diagram, I have shown you four type of transition. First transition is sigma to sigma star. Next transition is N to sigma star. Third transition is pi to pi star. And fourth transition is N to pi star. So how to understand these type of electronic transition? So for that, again we have to understand molecular orbital theory. The answer lies in molecular orbital theory. We have to see that we have three kind of molecular orbitals, or we have three kind of electrons present in molecular orbitals. Sigma electrons, second one pi electrons, and third one is non-bonding electrons, right? Sigma electrons, pi electrons, and non-bonding electrons. Sigma electrons, it is having sigma anti-bonding version. Pi is also having pi anti-bonding version, pi star, but non-bonding electrons or molecular orbital, they don't have any anti-bonding version like N star or anti-bonding, right? Now question is, why this non-bonding molecular orbital or non-bonding electrons, why they don't have anti-bonding? So the answer is, the reason is because non-bonding electrons, they don't participate in bond formation. They are not forming any bond. That is why they are not having anti-bonding. Sigma and pi, they both are participating in bond formation. That is why they have anti-bonding version. One more thing is here, you can see that energy gap also you can see. Okay, you can see the energy gap or energy order of these kind of transition. So now we are going to discuss four types of your transition. So we'll start with the first. The first transition is, you can see here, this is your first transition, sigma to sigma star. Sigma to sigma star transition. So as the name is suggesting, when the electrons are moving from sigma orbital to sigma star orbital, that transition will be called sigma to sigma star transition. Okay, now the question is, what kind of compounds show this transition? So the very first thing is your saturated compounds. Saturated compound means the compounds which are having single bonds without having any heteroatom like oxygen, fluorine or chlorine. So this kind of molecule, they will show sigma to sigma star transition, like your alkanes. So they can show sigma to sigma star transition. Next thing is that sigma to sigma star transition, it is high energy transition. In the diagram also you can see this is high energy transition. You can see the gap. The energy gap is very high. So it requires that high energy. And we know that energy is inversely proportional to lambda. So when energy is high, then lambda will be least. So for this kind of transition, lambda or wavelength will be least. Okay. Generally, your UV spectroscopy that has this range 200 to 400 nanometer, and visible spectroscopy that is having this range 400 to 800 nanometer. But sometimes some molecules which are showing this kind of transition sigma to sigma star, their energy is so high that lambda will be even less than 200 nanometer. That will be less than 200 nanometer. And that type of molecules will be studied when we will provide vacuum conditions. And that kind of spectroscopy is called as vacuum UV spectroscopy. That will be called as vacuum UV spectroscopy. Okay, so here the lambda will be even less than 200 nanometer. Then last point I am telling you that here electronic spin that will be retained, that will not be changed. So these are the main point of your sigma to sigma star transition. The very first point, it will occur in the saturated compound, means the molecule which are having single bond like alkanes. So they can show sigma to sigma star transition. Next point, as you can see, the gap is very large. It means it is high energy transition, and that's why lambda will be least. Lambda will be very less. And sometime for these kind of transition and molecule, lambda can even less than 200 nanometer. This is a special case, and then it will be called as vacuum UV spectroscopy. Then last is electronic spin, or your electron spin that will be retained here. Then second transition I am describing, this is your second transition, that is N to sigma star transition. N means non-bonding electron. So here the molecules should have heteroatom like oxygen, fluorine, nitrogen, chlorine, etc. because we need non-bonding electron. Okay, so these non-bonding electron, they are going to sigma star, right? So this kind of transition is happening here, means saturated molecules having heteroatom, saturated molecules, single bond containing molecules having heteroatom. So these kind of molecules will show you this transition. Next thing is, if we will compare this transition with first transition, so here energy gap is smaller. It means smaller energy will be required. Smaller energy will be required. Smaller energy will be required as compared to your sigma to sigma star. Then one more thing, that like your alcohols, ethers, aldehyde, ketones means carbonyl compounds, and saturated halides. For example, ethyl chloride. If I will take ethyl chloride, so that will also show this kind of transition because we have non-bonding electron, so they can easily go through this transition, non-bonding to sigma star. I hope now it is understood. Then we have third transition. Third transition is pi to pi star. This is your third transition, pi to pi star. Pi means pi bond formation, and we know that pi bond formation is possible in unsaturated compound. Unsaturated compound. Unsaturated compounds means the compounds containing double or triple bond. So all the double and triple bond containing compounds, they can show this pi to pi star transition. Then this is your first point, that what kind of compounds are showing this transition. Then we have, see, now if you will take alkene, alkyne, so they can show this kind of transition. And then if again you will compare the energy gap, so energy gap will be even less than these two previous transition. Means here also it requires smaller energy, it requires less energy than the previous transition, means sigma to sigma star and n to sigma star, right? And yes, now the last transition, which is your n to pi star transition. N to pi star transition. In this transition, the very first thing is what type of compounds it will show the transition. So we should have unshared pair of electron. Unshared pair or non-bonding electron should be there on heteroatom. On heteroatom like oxygen, fluorine, nitrogen, etc. to pi star. So this is the definition. Then second point, that here we need least amount of energy. Least amount of energy is required here. So when energy is least, it means lambda will be maximum. So here wavelength will be maximum. Then I am giving you the example. Suppose you have one saturated aldehyde like formaldehyde. So this kind of molecule will show, because here we have non-bonding electron plus we have pi star orbital also. Then one important question can be there. They can ask you the energy order of these all transitions. So energy order is 1 means sigma to sigma star, okay, that has maximum energy. Then second means n to pi star, which is greater than third. Third is your pi to pi star, and the least energy transition is n to pi star, which is fourth transition. I hope now you understood this topic. If you like this video and content, kindly like, share and subscribe. Thanks for watching.